Alright, so today, identifying transformation. So it says, use what you learned so far to identify each transformation. Give both a verbal description and an algebraic representation of each transformation below. So a verbal description is like, did it go up 3, down 5, left 2? Did it have a reflection on the x-axis or the y-axis? Did it rotate 90 clockwise? Those are words that you use to describe what happened. The algebraic expression is where you put like x plus 3 comma y minus 7. Or you switch the x and the y based on what your paper says. All right, so number 1. This is the original figure, so I'm going to put an O in it so we know that this is the original figure. This is the new figure because it's got the primes on it. So we need to talk about what happened. So looking at your paper, some people are like, oh my gosh, I know it went up. No. Okay, it did go up, but if you look at it, if you were just to slide this straight up, look where A is, C, D, D. Would it go right on top of this one? No, because the letters are not in the same order. The letters are moved around. So it can't be just an up. So then we're going to look at our paper. It's either got to be a reflection or a rotation. So remember, a rotation would spin it, so it would look like this. It would be sideways. So it's got to be a reflection. And it's got to be a reflection over which axis? The x-axis. So if I was to take this and flip it up, hey, look, my B is right here. So I flip it up, and there's my B right there. So it is a reflection. And that's on the x-axis. So I need to make sure I put that on there. And then it says an algebraic representation. So when you look at your paper with the boxes, it says on there a reflection on the x-axis does what to the values?
Y becomes opposite.
The x stays the same. X stays the same, and y becomes opposite. So x comma negative y. And that's coming just directly off your paper. If you're like, well, I don't know how to read my paper, then something else you could do is you could look at all the ordered pairs. Like this is -7, -3. But this A is -7, +3. So you could still look at it that way, so the x is the same, but the y is opposite. Oh, so if you didn't have your paper, you could do that. Okay. All right, number 2. There are 2 different answers for number 2. Okay. So let's all take a minute. This is the original, and this is the new figure. So you want to take a second and think, okay, what happened to get from the new to from the original to the new figure? So if you look at it, the H is at the bottom, but now it's at the top. The G and the E are switched. The H and the F are switched, so I know that that can't just be an up, down, left, right. It cannot be an up, down, left, right because the vertices are not in the same spot. So when we talk about translations, where it's up, down, left, right, the orientation does not change of the letters. They're always in the same spot. So that's how I can always first knock out a translation if the letters are in different orders. Does anybody have any ideas, maybe? All right, Trevor?
Rotation, 100 degree clockwise, and 180
Okay, so you're right. So let's just get to the part where it said it's 180 degree rotation. Okay, it is 180 degree rotation, clockwise or counterclockwise. Brody, you want to show your drawing book before I shut it for you? Okay, so that's one thing. If you look at it, so if he went 180 clockwise, it would have turned to the side, and then it would have turned to where it's at the bottom. So this F would have turned to the side, and then for another 90 degree, it would have turned to be to the bottom. So it is a 180 rotation. When I did it, I'll be honest with you all, like I said before, I'm not that familiar with rotations. It just wasn't really ingrained in our brains. I said, when I did mine, that it was a reflection over the y-axis, and then it was a reflection over the x-axis.
Oh my.
So it was a double reflection, is what I heard. So both of actually right. I went through and I checked all the points when I've been doing the papers. So it is a double reflection, or you could put a 180-degree rotation, and you can put on there clockwise or counterclockwise. It puts us at the same spot. Yes.
Do we call that like translated reflection?
All right. Now the algebraic representation of that. So look at your paper. What happens on a 180-degree rotation to the ordered pairs, Randy? -5. Yeah. All right, let's look at number 3. So looking at it, here's the original, here's the new one. It's got the same orientation. So when I'm looking at it, it's still facing the same way, and my points are still in the same spots. Look, here's I, J, K, I, J, K. So this is probably a what? A translation. So that means it went up, down, left, right, because nothing changed. The X and the Y's did not change. The vertices did not change. It's still facing the same direction. The points are still in the same spot. So that's how I know it's up, down, left, right. So I'm going to have to count here. I'll count from I to I. So it looks like I had to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like I went left 9. And I'm going to count to see how many it moved up. 1, 2, 3, 4, 5, 6, 7, 8. So it went left 9 and up 8. So to write that algebraically, the X went left 9. How can you show an X how you went left 9, right? But like algebraically. X minus 9. And then to go up 8, Y plus 8. So I really want us to focus here. If the vertices are in the same location, up, down, left, right. If they're not in the same location, then you're looking at a rotation or a reflection. Does everybody understand that? All right, I'm going to let you all try number 4. The reason my child's wearing that same outfit today. Blue hoodie and gray pants. Color are your shoes? Oh no. He's wearing solid black shoes. All right, anybody have any ideas on what happened to number 4? All right, Taryn?
90-degree rotation clockwise or 270 degrees counterclockwise.
Perfect. So this is the original because it doesn't have the primes. This is the new one. And once again, the orientation is different. The vertices, the points are not in the same spots. So that knocks out up, down, left, right. So if you put up, down, left, right, you did not pay attention to the location of the letters, the vertices. So then I think, okay, could it be a reflection? If I flip this up, does that match? No, so it's got to be a rotation. So to get from the original to the new, that's a 90-degree clockwise. Or like Taryn said, you could have went backwards and it been a 270 counterclockwise. Yeah. Yeah. All right, and then what does a 90-degree clockwise or a 270 counterclockwise do to the points? They switch and the X becomes opposite. So y comma negative x. And if you're not sure, once again, look at m. So that's negative 2, negative 2. M prime is at negative 2, positive 2. So this one became positive and they switched. All right, try number 5. Okay.
I'm stuck.
Well, look at the paper. Are the vertices in the same spots or are they not? That's where you start. The vertices are in the same spot, then it's an up, down, left, right. If they're not in the same spot, then it's either a reflection or a rotation. All right, this one should be fairly quick. What do we think this one is?
Translator.
It's a translation, and where did it go? To the right, how many? 10. And I know that it's a translation. P is where P prime is. Q is where Q prime is. O is where O prime is. R is where R prime is. So it's there. And then I can count. So if I count from Q to Q, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is a right 10. So it's X plus 10 and then just regular Y. It didn't go up or down. All right, try 6. Huh? Just look at your little paper, see what it says about reflection. If that's what it is. That's when I got suckers. I was like, oh my gosh, somebody's gonna slurp on their sucker the whole time, and I'm gonna be gagged.
I was like,
I know.
I was like,
All right, what did we decide this one was? Over what?
Why?
This is a reflection over the y-axis. So I'm gonna put reflect y-axis. And I know that because first of all, my points are in different locations. Second of all, if I was to rotate this original over here, it would turn and it would be more like this. So it'd be facing more like that. So it's not a rotation, so it's gotta be a reflection, and it is. It's just a flip right over, so it's a reflection on the y-axis. And on your paper, what does it say about reflection on the y-axis? Negative x. And you can check that, because this one right here is at 2, negative 2. This one's at negative 2, negative 2. So it is just the change on the x. All right, flip over here. All right, so this one, and we're not going to do what it says at the top, but it says, so it says that okay, so it says find the number you rolled and describe the transformation shown by the algebraic expression. So you're going to describe the transformation shown by the algebraic representation. So they're saying that all of these are the original and these are the new. So you're going to use your paper to tell me, is that up to right 5, reflection on x-axis, rotation of 90 degrees clockwise, just by looking at the points. So the first one's fairly straightforward. X plus 10. What does that mean on the x? You're going to go where? Right 10. And then what about y plus 5? Up 5. Right 10, up 5. All right, looking at number 2. it looks like the X is changing. The X is opposite, Y stayed the same. All right, Frankie? Yes, reflection over the Y-axis. And guys, with these, you just have to kind of play process of elimination a little bit. So if it doesn't have a plus or a minus on them, then it won't be up, down, left, right. If it's got a negative on it, it could be a reflection or a rotation. So that's why you're going to look at your points to see which one it is. So if they switch places, it's probably a rotation. If they're both negative, it's probably a rotation. If one of them is negative, that's when it's the reflection. So looking at number 3, it looks like the Y is negative, the X stayed the same. What's that one, Karen?
Reflection over the X-axis.
Yeah, so that's to reflect the X-axis that time. So you all take a peek at number 4. See if you can figure out what that is. I'll give you a hint. The X and the Y switched. So that's got to be a what? A rotation. So you just got to figure out which rotation it would be. And like Kate asked before, you only have to write one of them. You don't have to write both. All right, what did you get on number 4? Somebody different other than Karen or Frankie. Come on. All right, Isaac. All right, a 90 clockwise or a 270 counter. So I'm just put 90 clock. And it is because look, the X and the Y, they switch places. X became negative. All right, try number 5 on your own.
Oh, I was doing number 6.
No, well, you can do 5 and 6. Right. He's doing it on purpose. If you cannot eat your sucker properly, little boy, you're gonna have to throw it away.
Oh, she called you a little boy.
Brecken, you seem to be lost.
Yeah.
Yeah, I am. I don't know.
Yeah, Brecken doesn't know his left and right, or his up and down.
All right, well, Brecken doesn't know his left and right. Hopefully he got number 5 right.
Yeah, Brecken.
All right. Okay, so it's a left 2, because it's a -2 on the X, and then what's this -1?
That one.
Down 1.
I'm so proud of you.
All right, and then number 6. Both the X and Y are negative, so everybody, this is a 180 degree rotation. So 180, and we can put clock or counterclockwise, it doesn't matter. All right, shifting down here to the last part. We're not going to do the spinner here. We're just going to answer them in order. Okay, so it says, answer the question you land on and record your answers to the right of the spinner. So we'll start with point A. So it says point A is at -9, -3. If it is translated 4 left and 2 down, where would A prime be? All right, Blake, what do you think?
It would be -13 and -1.
Beautiful. Because look, a 4 left would actually subtract 4 from the X. A 2 down would subtract 2 from the Y. So that's at -13, -5. He's right. All right, look at point B. So point B is at -5, +5, and it's reflected over the X-axis. Where would B prime be? So look at your papers. Look what it says about a reflection over the X-axis. Right? Somebody different, somebody new, somebody fresh. Oh, come on. All right, Sherman, do you have an answer?
-5, comma, -5.
-5, -5, because a reflection over the X-axis takes the Y and makes it negative. So that's how I knew to keep the X the same, make the y negative. It says it on your paper. Okay? Alright, on point C, it says point C is at 7,6. You're gonna rotate it 180 clockwise. Where is C prime? So on your paper, a rotation of 180 clockwise makes both of the points
Negative.
opposite, so negative. Alright, Kate Campbell. -7, -6, because a 180 clockwise would take me -x, -y. That cord that cord down here that is in here,
Yeah, I just want to replace your speaker.
yeah, it's wallered out. So like it doesn't like stay in, it keeps falling out. Yeah. Alright, guys. Alright, Blake wants to tell us the answer to D prime. So -8, -1 is reflected over the y-axis. So when I reflect it over the y-axis, it changes what value? Dx. So Blake, what is your new order pair?
8, -1.
8, +8, because it changes the x, the y stays the same. So 8, -1. All right, and then the last one, point E, is at 2, -4, and it's rotated 90 clockwise. Eli Money.
-4, -2.
-4, -2.
I guess it's right up here.
And that is right, because with a rotation of 90-degree clockwise, the x and the y switch, right? And then which one becomes negative? Huh? Huh?
Oh, no.
The Y. So the x and the y switch, wait, no, I did that backwards. The x becomes negative. So that paper right there is a lifesaver. That paper you have to bring with you. I will allow you to use it on your quiz and your test as long, one stipulation, as long as you don't write on it. So I mean, your name can be on it. But other than that, when we go to take our quiz and our test, I'll check papers to make sure you didn't write anything on it.
I may have wrote it in eyes.
Okay, I'm gonna pass out the next paper here. Let's turn this off.